I'm actually, while I'm over here in Australia, I'm staying in Coburg with a mate of mine. I don't know if you know Coburg, it's a suburb of Melbourne. It's exactly like Hamburg, except it's contravariant in its first argument. So I haven't quite decided if this talk is an experience report or just some cool stuff you can do with Haskell. Whichever type of talk you prefer, pretend it's that one. I'm a contractor, and I contracted for a Haskell startup about 18 months ago, and it really impressed me. Technically, it was one of the tightest startups I've ever worked with. And it was the first time I've worked with a startup that used Haskell. And when I first heard about it, I thought they were mental. And by the time I finished that contract, I thought, I'm never going to write software a different way again. It was really cool. Normally, as a contractor, when I do a lot of front-end work, and when I go in, there are problems I expect to live with. And we actually didn't have any of the problems I'm used to dealing with in web startups. We didn't have this constant problem where there are 20 endpoints, and they all have a slightly different way of representing phone numbers. You know, that's a very common one. What company I'm working for at the moment has time ranges. And there are about 3 different ways of representing time ranges. And that problem disappears by using Haskell. And as a front-end programmer, you often come up with ways of wanting data from the back end, which they hadn't accounted for. And how quickly can you get the back end changed to give you what you need to render the UI that the business wants? That's a big problem. And I was almost never left waiting for those sorts of changes with a Haskell startup, because they just refactored it, and boom, it worked. And it worked reliably every time. That was really pleasant to work with, and a lot of the kind of day-to-day problems I'd expect vanished just by them using Haskell. But we still had problems. Those have sort of niggled at me over the years, over the months, I should say. So the problems we had, the biggest cause of problems I found as a front-end developer with a Haskell backend is database queries exploding at runtime. They do something new, they change what the endpoint's going to return. First time it runs, it explodes in a corner case of SQL. That happened. And probably a bigger problem is the front end and the back end disagreeing. I'd ask them to make a change, it'd be my job to update it. And there's always a lot of work in keeping those two in sync. And actually, I realized that these 2 types of problem are exactly the same problem. The back end has changed, the database doesn't match it, or the back end has changed, the front end doesn't match it. How do you keep those 3 tiers in sync? Is the big question that I haven't seen solved well. The schema synchronization across 3 different tiers. How do you keep them consistent? Can you get like the same types of things, so we're all agreeing on domain representation the whole way across? And can you do it reliably and cheaply, so that you still get the speed of development that I liked about working with a Haskell startup? One solution I looked at was, let's have one language everywhere. I don't have time to go into the reasons I threw that away, but if you're interested, ask that as a question. No, not good. The second solution, which is what I really want to talk about in detail, needed some setup. And I'm going to talk about the kind of setup I did. So the back end, for a Haskell program, the back end part of this is mostly solved if you're using Persistent, which is a popular database library. And it does this nice thing where it generates database migrations. You define the schema in Haskell. It looks something like this. You can sort of imagine this is somewhere between a Haskell data type and a database table. And it's exactly that. This code will generate the Haskell type. But it will also generate one of these, which is a kind of automatic migration type. And as well as generating all the code you need, it generates this thing which says, look at the database, see what's different, and try and change it automatically. You run it as simply as that. You just put your connection details in. And you end up with the database looking exactly like Haskell, which is great. And then you come and make changes. And whenever the program runs, it says, oh, I've just checked the columns, and this column is missing, this column needs changing. And it works really nicely. Most of the time, it's totally seamless. And the rest of the time, it stops and tells you which SQL queries you need, which DML statements you need to run in order to make the backend and the database agree. And it sort of says, you need to do this, I'm not taking responsibility, but if you do it, they'll agree again. It's surprisingly seamless. I found this works really well in practice. And it's almost free, which is nice. The front end is a meatier topic, right? And for me, this is the interesting Haskell foo part. How do you get the front end to agree with the web server? And the solution I've hit on is, well, let's do basically the same thing. Let's get Haskell data type definitions to generate front-end code, which will only work for some languages. It's not really going to work for JavaScript because the term is almost meaningless, right? You could generate some REST API code, but then the rest of your front end won't agree. But it works nicely for certain languages that sit well with Haskell, and Elm and PureScript being the obvious choices. So I've been doing this for Elm for about 6 months, and I have these keen Elm badges. If there are any Elm programmers here in the room, yes, you get a badge. I've got 2 badges to give away. Luckily, I brought 3. So there's this mechanism in Haskell called generics, and who was it? Finley was pointing towards it earlier as an example of using it to automatically generate binary formats for data serialization. But you can actually use Haskell generics as a way of saying any data type has a certain structure. If I turn that structure itself into data, I can run a function over the data and get something else out. So what you end up doing is saying, tell me the generic structure for my person data type. You get some data that describes the data type itself, and you can say, oh, I'll write that out as an Elm declaration. So if we look at a couple of examples, this is a maybe type. Everybody familiar with maybe or option? I'm assuming, yeah, from the day's audience, yeah. So you can say to Haskell, what is the generic structure of a maybe? And it comes out kind of how you'd expect. You get, there is a data type. It has some stuff in it, including the string maybe, which is the name of the data type, right? And that's made up of 2 constructors, sort of added together, ored together, I should say. One of them has got some information about it, including the string nothing, which describes one of the constructors. And the other one and has no parameters. And the other one has a string just, and it has a field without a record selector, which refers to another type A. So you get this sort of. It's almost easier to say, how would you describe a maybe? Well, you'd say it's a type called maybe with, you can either construct it with something called nothing or something called just at the parameter A. This is almost an encoding of that sentence that you can get out for almost any Haskell data structure. Let's do it for another custom type. If you want to do it for a custom type, you have to say, derive a generic representation for it. That's all you have to do, and then you get this structure out, which is very similar. You can see how that is a sort of description of the actual Haskell data type. So you can do cool things with this. And there are actually very few rules. This is why this works. There are very few rules for describing a Haskell data type. There are data type declarations, like data may be A. There are constructors, which is like person or nothing or just. And there are fields within those constructors. Those are the metadata types. There are references to other types. So like person may have a string in it. And the generic representation of a person doesn't tell you what a string is. It just sort of says, there are strings. Go and learn about those elsewhere, but I need one. And then there are abstract, like variables, so just A. And then you can combine things together with and or, ADTs for the win. And then there are a couple of extras, like some constructors don't have fields at all, like nothing. And some data types don't have constructors at all. They're just kind of like phantom types. And that's pretty much all the rules you need to describe any data type in Haskell and start playing around with it. The only rub in this is it's got a horrible API. It's really, I don't know why it's written like this unless the person that wrote it forgot to switch on autocomplete and didn't know how to touch type. Because instead of writing constructor, they write things like C1. And it's just full of this, why this is not helping anybody. Just type it once and then autocomplete it, and we can all learn about this. It's really horrible. Is the author of this library in the room? I'm sorry. But if you get past that and the usual friendly Haskell documentation, you have this really nice way of, it's not brilliant to work with, but you can say, OK, I've got a data type which is called person. So I will write out a string that says the Elm equivalent, which is type alias person equals, and then I'll look at the next bit and see what it can equal. And you gradually walk through. It's like walking through any data structure and spitting out a string. It's actually quite easy once you've got through the API. This is how you would actually use this. I'm going to skip over some of the nitty-gritty and just show you what it ends up being like in reality, which is you just say, oh, I've got this pre-existing data type. I'll derive generic from it. Because of that, I can derive an Elm version of that type. And then I can run this code, which converts one of these into some source code and adds a preamble. And I end up with Elm code generated from Haskell code automatically, and it's always an agreement. I spit this out, I go to my Elm project and compile it, and either it works, or I get an exact list of all the places it doesn't, which is the joy of typed functional languages. You just get this shopping list of things you need to fix, and when you fix them all, it probably works, which is sweet, right? And it's incredibly cheap once you set this up. Because another way to handle this is barrages of unit tests, which are great. And unit tests and types aren't the same thing, but where they do intersect, types are much cheaper and much faster. So having this kind of consistency check across all three tiers is really cost effective. And that's how I would sell it to management. I'd give them this talk as well, because they'd love that. That's available if you want it on Hackage. You should probably say it's not possible to represent every Haskell type in Elm. But I think for every type that you would want to transfer across the wire, it covers all those cases. And if it doesn't, let me know, because I would like it to provide that guarantee that if Elm can use it, then Haskell can generate it. And the net result is Haskell is great. This is my sales pitch. Haskell's great. You can catch loads of errors at compile time, where it's cheap and easy. Elm is great. You can catch loads of errors at compile time, where it's cheap and easy. And the great thing about types that unit tests don't have is it tells you if the entire system hangs together. You know, unit test doesn't tell you if the relationship between every part that cares holds. And that's something I like about typed functional programming. Postgres has a kind of similar guarantee in that relationships are enforced at compile time. The schema has to agree with itself. That's quite good. Put them all together, and you catch that last class of errors that I was worried about this startup I contracted for. And really, these days, with this kind of stack, the vast majority of my errors come from the Google Maps API. That last 5% I can't get rid of. And you've got this guarantee that keeping the whole system consistent is actually very cheap. It's nice. If it becomes inconsistent, you get a complete, accurate report of where the inconsistency lies, hints on how to fix it, and only the minimum amount of work necessary to actually fix it. So If you're tempted by a mean stack, may I introduce you to help? Although you could apply this idea generally. I'm sure Scala has something similar to GHC generics, and I'm sure if you wanted to swap out Elm with PureScript or something, this idea would drop in very easily. But the big idea is we have the ability to keep the entire thing consistent cheaply, and it's really worth doing. Microphone delivery.
All the way up there. Copy.
Thank you, Kris. I've been looking for something like this for months on the internet. I just couldn't find any talks or blog posts, and it's really cool that you've kind of cracked this story, or at least I hope you have.
I'm claiming to.
I've always been really curious about how come the attempts to get Haskell into JavaScript weren't working well enough, and why PureScript and Elm needed to come along to fill the gap. And maybe you can help me.
Do you mean why Haskell isn't used more with JavaScript? Or do you mean why...
The compilers from Haskell to JavaScript.
I think... So GHC.js is the kind of Haskell, is the go-to Haskell to JavaScript compiler. And it's really good and it's really impressive. Like, you can just download regular Haskell packages, and for the most part, they will seamlessly compile to JavaScript. It is really good. It's an impressive piece of work. It's done by one guy who is clearly overloaded and has a colossal amount of work to do to get it in production. I think it's definitely one to watch, and if anyone works for a company that wants to sponsor that one guy, you'll be doing the world a great favor. But today, it's just not production ready, in my opinion. Sorry? The Elm guy. Yeah. It really helps. And find a good language designer. They're pretty cheap to sponsor compared to the enterprise contractor who will charge you a fortune to fix the mistakes in JavaScript. I do have, if you're interested, I've got a blog post on different Haskell likes to JavaScript. Incidentally, anyone can make that offer. That's fine.
So I was noticing that there weren't any Elm talks on the roster, and you started talking about ClojureScript. You were hired by a company that did ClojureScript and Haskell,
yeah.
And Elm suddenly surfaces from the talk.
Yeah.
So I would like you to talk, if you can, about that transition.
Okay. Honestly, I think it's very hard to make a bad decision in which language you use for the browser, as long as it's not JavaScript. I'd been writing a lot of Clojure at the time, and I was using ClojureScript, and it works really nicely. ClojureScript I would still recommend to people. Having worked for a Haskell startup, it's like functional programming is the big idea, but once you've got that big idea, typed functional programming is really sweet. I think FP is a bigger idea than types, but if you've got that idea, types really do help. And that's when I've been sold on Haskell, I started looking around and saying, well, can I get all the benefits of Clojure and ClojureScript, plus the benefits I'm seeing from Haskell? And so I looked at GHC.js and thought, not quite. I looked at PureScript and I thought, not quite. It has improved a lot since I last looked at it, and it's still a good choice. I looked at Elm and thought, yes, this doesn't have everything I want, but I can ship with it today. It gives me everything I like about ClojureScript and a lot of the things I like about Haskell.
Any more questions?
One more?
Can't see any hands.
Just down the front.
Oh, yep, cool.
Just putting together a stack for my next startup, and I come onto F# and Web Sharper, which does a very similar thing to this. Not only gives you the front-end, back-end consistency and does F# into JavaScript, so you never see any JavaScript, but it also gives the UI composability in FP as well. So it's really good.
Okay, I should look into that. I don't really look much at Microsoft stuff, but I'm becoming increasingly convinced I need to know something about F#.
In this help stack that you've got, you're transforming your data types in Haskell to Elm. Are you doing anything to handle some of the transport and protocols and all that sort of stuff?
So there's also, having done this kind of generic representation from any Haskell data type to this is what the Elm structure roughly looks like, I've got 3 writers, one that writes out data types, one that writes out JSON encoders, and one that writes out JSON decoders. And you need all 3 explicitly in Elm for technical reasons, but you can generate them all automatically from exactly the same idea. Yeah.
It's really awesome, man. Well done.
Thank you.
Anybody else? Can you see anyone in? All good?
Nope.
Sweet. Okay, thank you so much.